Okay, students, today we will discuss about the numerical methods, and the topic is geometrical concepts of root finding methods. According to the WUT syllabus, this topic is very much important for 3rd sem EEE, 4th sem ECE and 6th sem CSE students. So, as a student of science and technology and engineering, we have to face frequently the problem of finding the roots of an equation fx equals to 0. So in your syllabus there are three methods. One is bisection method, and second is regular Falsi method, and third, that is most important, is Newton-Raphson method present in your syllabus. Okay, so before going to the deep of this topic, we have to know some facts. Like, first of all, we have to find the location, that is a interval a and b which contain the roots. Okay, that is at the point x equals to alpha where fx equals to 0 is satisfied. So to find this approximate interval ab, there are two methods. One is graphical method and another is tabulation method. In graphical method, we just try to sketch the graph of y equals to fx roughly in xy plane, and we can find a small interval ab where the root situated. And in tabulation method, we just use a theorem which is named as intermediate value theorem, which states that when f of a into f of b is less than 0, that means f of a and f of b are in opposite in sign, then there exists at least one point C in between a and b where the curve intersects the x-axis, that is, which is our required root. So using this theorem, we tabulate the functional value for different values of between a and b, and we can find a suitable small interval ab. Now there are some assumptions required. One is the starting position x0 hopefully close to the root, and the root is simple in nature in this subinterval a comma b. Simple means where f of alpha equals to 0 but f dash alpha not equals to 0. And also we have to consider the function is well behaved, that is continuously differentiable up to sufficient number of times. Now the first method, bisection method. So in bisection method, we choose a subinterval, suppose AB. We termed here x plus and x minus, because here f of x minus is less than 0 and here f of x plus is greater than 0. Sorry, it is just mistaken. It will be greater than 0. Okay. Now in this method, we first bisect this subinterval, this interval x minus and x plus, and we term this midpoint as a x half. And again we check that f of x half is 0 or positive or negative. If f of x half is equals to 0, then it is our required root, and if f of x half is greater than 0, then we take x half as our new x plus. Okay, just, and x minus, if and f of x half is less than 0, then we take x half as our x minus. So we can see that in this picture that f of x half is negative. That means we take x half as our x minus. Okay, so we see that again the roots lies between the new x minus and new x plus, and again we bisect this interval, and similarly we can get our required root. Okay, this is the fundamental concept of bisection method. This method is surely convergent if the function is continuous, and the convergence rate of this method is linear, that is 1. Okay, the second method, that is regular falsy method. This method is also known as the chord method. Here in this method we have to find two initial guesses like above, x0 and x1, which contains the required root here. Okay, now we join the point 1 and the point 2, and the point where this chord intersects the x-axis, we term it as our next approximation. And now we have to check the root lies either this interval or this interval. So here we see that the root lies between the point 3 and 1. So we draw a chord between 1 and 3, and this intersects x-axis at here, and similarly goes on, we can get the required root. And the convergence rate of this method is faster than bisection method, and which is near about 1.6. Now the most important or best known algorithm for getting quadratic convergence when derivative is easy to evaluate of a function, which is known as Newton-Raphson method, and sometimes it is called it also called tangential method. So in this method, suppose y equals to fx curve is our blue curve. Okay, sorry, blue not green curve, and now here we choose an initial guess. Here this is our x0. Now we draw a tangent at the point 1, and this tangent cuts the x-axis here, and we take this as our next approximation. And again we draw a tangent to the curve at the point 2, and we see that this cuts here, and similarly goes on, we can get the required root of this equation. Okay, so the iteration scheme of this method is looks like that. Here minus f of xn by f dash xn, it is called increment. Okay, this is our required. Now the rate of convergence of this method is 2, which is very faster than bisection method or Newton regular falsy method, and the convergence criteria of this method is looks like that: fx into f double dash x whole mod is less than mod of f dash x whole square. Okay. So thank you. If you have any doubt, please feel free to ask me in comment section.